Question 14. An object is launched upward at 64 feet per second from a platform 80 feet above the ground. The function s of t models the height of the object t seconds after launch. If s of t equals negative 16t squared plus 64t plus 80, state the vertex of s of t and explain in detail what each coordinate means in the context of the problem. After the object is launched, how many seconds does it take for the object to hit the ground? Justify your answer. So the first thing is, obviously, I've got a function. I want to go to a graph page. So home screen, new doc, say no to drugs, and add a graph page. So notice f1 of x. This is a function in terms of x. So I can start with that negative 16, but I have to say x squared, not t squared. Then add the rest of our function plus 64x plus 80 and enter. This is my graph. Now, at a glance, this looks like two lines. I don't see the parabola, but if you notice, this thing goes all the way up to 80, and my window really needs to be from like 0 to 8 is plenty. So I'm going to make a custom window. Menu, 4, 1, and I'm going to say my x-min, I'll do negative 1 to 8, and I'm going to count by ones. And my y-min, I'm going to say negative 10 to 90. Well, no, wait. Pause. I know I want to get to at least 80 to get to where my y-intercept is, but the vertex could be a lot higher. So I'm going to make that 210, and I'm going to count by tens and say okay. So now I have the top of my graph, I have the bottom of my graph, so everything's good. So now I need the maximum. Menu, 6, 3. I set a lower bound to the left side of the top, anywhere over here. I press enter exactly one time. Now it changes to upper bound. I drag to the right, and my maximum is 2, 144. So when I explain my vertex, I have to explain the x and y coordinate. So in context of the problem, the turning point vertex is the maximum value of the function. At time t equals 2 seconds, the maximum height of the rocket is 144 feet. So that explains my vertex in the context of the problem. Now, the other question is, after the object is launched, how many seconds does it take for it to hit the ground? So back to our calculator, notice when I look on the left-hand side, over here are the negatives on the left of the y-axis. I don't care about that because it doesn't really exist. This rocket started 80 feet in the air. So really what I care about is this on the right. So menu, analyze graph, I want the 0. And again, my lower bound, anywhere to the left, I press enter exactly once, drag to the right, and the 0 of this function is at 5. So t equals 5 seconds is when the rocket hits the ground. And that puts everything in context. We have our two key points, the vertex and the 0 of the function, all put together in one problem. And that is our 4 points complete credit for question number 14.